Recently, we have been studying about the perimeter and area of different two-dimensional figures. We discussed the circles and quadrilaterals and triangles. In this lesson, we're going to talk about finding the area of a different kind of object. Take a look at this green handout and look at the 4 different objects. Have you ever seen any figures like these before? How are we going to find the area of these strange figures? We had recently learned the formulas for all of the regular two-dimensional figures, but these irregular shapes, how do we apply those formulas to that? Strange. This number 2 here looks like you might find on a basketball court. Maybe number 4 looks kind of like maybe a swimming pool or something. And number 3 looks kind of sort of like a baseball diamond. Number 1 looks kind of like a boot with a pointed toe. Anyways, let's try to be a little more imaginative. What if these figures were like puzzle pieces? You know, puzzle pieces look kind of strange, but let's pretend that these figures are maybe made up of more than one regular shape. So what if on number 1, by making that mark, how many figures do you have now? 2. And what do you see? What do you observe? A rectangle, okay, and a triangle. Okay. Could you find the area of the rectangle? Okay. And could you find the area of the triangle? All right. And once you have the area of this figure and then the area of this figure, what would you have to do to get the total? Oh, you would just add them together. Okay, that could work. Let's look at the next one. Number 2, what 2 figures do you see here? Do you see a rectangle? And what other figure? Half of a circle. How could we find those areas? Well, this would be Again, length times width. And then for the circle, you would have A equals pi r squared, and then divide it by 2. Why? Because you only have half of the circle there. Okay? And actually, do you know the name of this figure right there? Anybody know what it's called? It's called a semicircle because it's half of a circle. Okay? So again, you would find the area of this figure here, and then you would find the area of this here, and you would add them together. Excellent. Let's now look at number 3. What could you do there? I see a couple of different things. Probably the easiest to identify would be a rectangle, which would be length times width, and a square would be s squared. That's easy enough. What about number 4? You could take this line right here, and if you continued on, what would you have? Yes, you would have a parallelogram, which is just like a rectangle, and then you have a triangle, which would be base times height divided by 2. Excellent. Very good. This half page needs to go into your Cornell notes. So you'll need to either glue it or tape it onto your page for the day. Now let's look at this second half page handout. This will also go into your Cornell notes for the day. And let's take a look at the paper here. Okay. Anyone know what this graphic organizer is called? Yes, it's a Freyer model. And what you'll need to list here is, we're going to talk about composite figures. So after our little conversation that we had just completed, what is your definition? What are the characteristics? Give me an example and a non-example. Now, what did we end up doing with those new figures? How are they made? They're composed of 2 regular figures. And that's why they're called composite figures, because they had been composed of 2 or more regular figures. Okay. Let's look down here. So we just talked about determining the area of a composite figure right here. How would we do that? Do you remember? I'm going to let you write that in your own words. And then to determine the perimeter of a composite figure. Now we hadn't yet talked about that, but thinking about perimeter, remember that perimeter is like a fence that you're going to put around the garden. Okay, so how would you measure that? All right. Let's look at these problems here. Number 1, Ahmed is installing a deck in his backyard using the plan below. What is the total area of the deck? Well, first of all, let's try to visualize. What are the shapes? Okay, what I see is a rectangle here. And remember this figure? Yes, a trapezoid. Okay, so it looks like we're going to have A equals, let me change my color here, because I want him to match. There we go. So A equals length times width for that. And then we're going to have A equals, remember, base up 1 plus base up 2 times the height divided by 2. Okay. So let's do the area of this first. Okay. 12 times 9 is what we're looking at. Okay. And what is 12 times 9? 108 square feet. All right. So now we're going to find the area of the trapezoid. So this is base 1, so that would be 6, plus how far is it here? Oh, it's the same as this, so it must be 12. Okay, and then the height. Well, this whole thing is 12, but this is 9. So how tall is it from here to here? Okay, that would be 3. And then we divide by 2. Okay, so 6 plus 12 is what? Okay, 18. And times 3. And then divide by 2. Okay, so 18 times 3 is 54. Divided by 2. And then that will equal 27. So this is 27 square feet. Are we done with the problem? No, because now we have to add. Okay, so this would be plus 27. I'm just going to add it right here. So this 7 and 8 is 15, 2, 3, and 1. So our total is 135 square feet. Now let's look at the second one. Number 2, Chris is purchasing border plants to outline his garden. Okay, so what are we talking about when we're looking at outlining? Good. Yes, we're talking about the perimeter, correct? Okay. So on this particular figure here, we have these dimensions. We have, it looks like, obviously a circle, but we also have this shape here. It's 5 by 5. So what does that tell you about this figure? It's a square. That's correct. So it looks like we have a square and a circle. But remember, we're only looking for the outside edges as an outline. So what I see, this is 5, this is 5. So now we can use this 5 as what dimension of the circle? Yes, that's correct. It's D, which is the diameter. So D equals 5. All right, so now what formula am I going to use? Okay, C equals pi times the diameter. Okay, so that would be 3.14 times 5. So 3.14 times 5 equals 15.7 feet. Are we done? No, because now we have this side and this side that we need to add to it. So 5 plus 5 is 10. Don't forget to line up your decimals when you're adding because it does matter. So we have 25.7 feet. Okay, and that is our answer. Very good. Now let's take a look at your assignment for today on this handout entitled Shapes. This is kind of like the table that we completed the other day. We are asked to find the perimeter here of a given shape and the area of the given shape. And if you notice, we have a few more different shapes this time, okay? Now, what you're going to have to do is follow the instructions. So let's read. It says, use a ruler to measure and label the dimensions of each figure to the nearest half centimeter. Be sure to label the dimensions inside the figure. So in other words, what you'll need to do is, let's say if this comes out to be 5 centimeters from here to here, then you want to make sure that you put the measurement here. So it'd be 5 centimeters. Now, I don't have a ruler, and if I measured it, my measurements are going to be off from yours. So you're going to have to measure that on your own, okay, and determine the actual measurement, okay? So remember that use the measurements and then use 3.14 for pi if needed on the circle, okay? It says to cut out the shapes, but we're not going to cut out the shapes just yet, okay? I want you to find the perimeter in the area of each of these figures. All right, and I believe that will get you quite a ways through this assignment. Remember, when you're looking for the dimensions, don't forget to recognize the height here. Remember, it has to form a 90-degree angle. And the height here. Okay? And then also, when you're measuring for circumference, you can use the diameter. Okay? But when you're looking for the area, you only use the radius. This assignment will be due on Monday. If you have any questions or didn't quite understand it, please feel free to play back the video as often as you need. Thanks for watching.